My name is Neil Patwari. I'm going to tell you 6 things about antennas that wireless system designers should know. This is part of a series of videos about digital wireless communication systems. If you want to see more, you can go to this website. Antennas are passive. They don't create power, they just convert electrical energy to electromagnetic wave energy. And there's some loss in the antenna, the connectors, the cables leading up to the antenna, but they definitely do not create energy. The second one is that antennas can't be isotropic. That is, they can't send power equally in all directions. So how much does it send power in each direction? That's where we define an antenna gain pattern that compares the power gain in each direction to what it would be if it was isotropic. We call this G of theta phi, where theta and phi describe the direction, the angle on the azimuth and the angle from the horizontal plane. This gain pattern tells us what to multiply the power by to account for the fact that the signal left the antenna at this direction and experienced this power gain. Oftentimes you'll see the gain function represented in dB, that is G with the dB subscript, and that dB version of the antenna gain pattern tells us what to add in dB to the power of the received signal. But here I'm going to talk about this linear gain pattern function. The third thing is that the maximum of the gain pattern GV is confusingly just called the antenna gain. It's confusing in terms of words because we're using gain for the same thing, but if I say gain pattern, then I mean G theta phi. If I say antenna gain without the word pattern, then I mean the maximum of the pattern. The fourth thing is that bigger antennas have higher gain. So, for example, in microwave relay antennas, like this one on this tower in Kansas, these antennas are very big because they're trying to maximize the range of the microwave relay link, and the physically bigger antenna gets them that bigger power gain, which gives them a longer range. The fifth thing is that pole-shaped antennas are omnidirectional in the horizontal plane. That is, they send power equally in every direction in the horizontal plane, but not much out of the ends of the pole. So it's not isotropic, but it is sending power equally along all of the directions perpendicular to the pole. They're called dipoles or monopoles. This image is at the top of Hidden Peak in Snowbird, Utah, with these omnidirectional in the horizontal plane antennas used to cover the entire mountain area in all directions. The sixth thing is that directional antennas have a horizontal beam width and a vertical beam width. This beam width describes the angles that are less than 3 dB down from the maximum gain. So in this plot of a directional cellular antenna, you can see that in the vertical plane, there is some narrow that are range of angles 3 dB down from the maximum peak. This angular width we would call the vertical beam width. And in the horizontal plane, you can imagine that we could draw the same thing. We could see the angles from one side to the other that are within 3 dB from the maximum of the antenna gain pattern. And these are described as the horizontal and vertical beam width. The larger the vertical dimension of the antenna, the smaller the vertical beam width. And conversely, the smaller the dimension of the horizontal beam width, the wider the horizontal beam width is. So you see this very tall and narrow antenna has a very small vertical beam width and a relatively large horizontal beam width. So these are the 6 things that I think every wireless system designer should know about antennas.